Hello everyone, it's September 7th. Finished the book from James Patterson. It was alright, but yeah, like I said, definitely not my type. So I'm going back to sci-fi. I'm going to read Leviathan Wakes by Corey. James is a Corey. And actually I have another one from Arthur C. Clarke just by my desk. So I can choose which one I want to go. Alright, so today we have another easy one, and this is a really easy one. So we're going to hit this, and we're going to try this one. Let's just done with this. Man, we don't even have to do, we don't even have to do much things. It's very, very straightforward. And I doubt, yesterday was terrible. Yesterday's supposed to be an easy problem, but I wasted a lot of time trying to figure out what it actually wants. But today is different. Today is just in order, right? Wait, what's in order? Root, left, right, right? Now is that pre-order? Wait, hold on. No, it's root. Yeah, root. No. That's 1, 3, 2. No, it's left, root, right. That's in order. The root, left, right is pre-order. In order is left. So say if root, right, and then, oh, hold on. I'm going to return a list. My bad. We don't have to return anything. If node, dfs left, start append, file, dfs node right. That shall do. So I think we'll have to also, that's about what it needs. Yeah. .94. Okay, so that's that. Let's try this one. Find a peak element. A peak element in a 2D grid is an element that is strictly greater than all of its adjacent neighbors. Okay? Given a zero-indexed MN matrix, or no two adjacent cells are equal. No two adjacent cells are equal. Find any peak element and return the length to array ij. Hold on. Find what? Any peak element. Any peak element, not all. And then return the length to array. Oh, that's not difficult. Oh yeah, I was just going to say you can just OMN, but they don't allow you. So we can return this or return this. Return this or return this. So we want MlogN. Oh yeah, it's gonna time out if you do. Maybe you won't time out. Okay. want to find something that is the largest. The first one that we find. Thinking about binary search, but I don't feel like it. I don't feel binary search though. Like if we go row by row, then each row we should only take log n time. Then we can go m of them, right? How do we do that? In log n. That is challenging. Binary search. Or we can say like we want to find the largest. Find the largest. Not necessarily needs to be largest. I have no clue. Wow. And the initial is, oh, you use this. No two adjacent cells are equal, so they are all different, right? So all the values are unique. All the values are unique. How can I use this? All the values are unique. which means in a row, I don't know, man. It just doesn't feel, there's no order, right? No two adjacent cells are equal. Oh, no two adjacent cells are equal, but it doesn't mean everything is unique. It just means, like, this one can be 30. Alright, this is still legal because the adjacent cells are not. I mean, this is trying to say that it will definitely exist, or maybe it won't. Maybe we start from here, right? We start to go, and we look at the 4 nearby. If this one's already the largest, then we're done. If not, we jump to the largest one. And from here, we follow the same, we jump to the largest one. So every step, we jump to the largest one. Every step, we jump to the largest one. I don't know if I can prove, but I think this... Let's write both solutions and then see if this is faster. Yeah, I mean, we need to prove that that's MlogN. I don't know. But that's just my idea right now. Just every time we always go to, it's like greedy, right? It's like greedy. We always go find the largest. Like every step we find the largest. And because they're not, the adjacent cells are all unique, right? So for every step, if I'm not the largest, I always go closer to the largest. So here's my solution. What I'm going to do is that's going to be a DFS, right? I and j, and then return a list of int. Okay, we say for didj in, right? For didj in 0, 1, 0, -1, 0, -1, 0, and ij, I plus di, j plus dj, right? And we need the maximum, right? The max. So max I and max j equals ij, right? And then if 0 smaller or equal to I need m and n. So m smaller than ni and 0 smaller or equal to n. What the hell, man? Sorry. nj. Right. And then we say if mat ni nj is larger than mat max I and max j, then max I max j equal to ni and j. So we'll go through this. Actually, we can just put it here and, all right. Well, we go through this and we say if max I, we can say if max I max j is equal to ij, then we return ij. So we already found it. Else, we're going to return dfs max I and max j. So we just return dfs 0, 0. Let's see. So the answer is 0, 1. The answer is 1, 1. Okay. We try this. I feel because every step we're going towards, I'm not sure the runtime of this, but well, we try. That was bad. That's not. So I keep searching a bigger one, bigger, it doesn't work. Yeah, this definitely does not look like MlogN. 1901. No. This method tries to this method always goes to DFS, right, to the biggest neighbor, right, until there is no more. Yeah, we did do some, repeated, but it's okay. So we have to go through all 4 anyway. Until the current cell is the biggest. I think it is faster than brute force, but it is kind of brute force as well. It's not a log time complexity. No, because the worst case scenario, I can see that we will do, OMN. This is OMN, which actually might be slower than the actual OMN. We can write a stupid OMN and just see how that goes. That's solution 1, right? And then we can do a stupid OMN. So this is the true, this is the most generic, most straightforward, most naive OMN solution. Right, and just say for I in range, this might be actually faster. All right. Okay, so we say found is true, and then we say and this one is smaller than ij. No, if it's larger than ij, then break. All right, else turn ij. Yeah, then we need this. Okay. Yeah, add a hint, add a hunt. This might be actually faster. Huh? Not really. Yeah, it is. It's slightly faster. But still, that's not what the question is asking for. The question is asking for MlogN time. So we need to create, right? We need to create some sort of order from this. And what we can do, usually, if we want to create an order, we can use a prefix sum is an order, but I doubt it works here because I don't see how that works. Or we can say, I don't know, monotonic stack. We have a long one, and we go through, but that's ON, right? Monotonic stack requires ON. Or I pick the largest, but that's ON already, right? That's the largest one. And I don't even need to do this. We just find the largest one. Yeah, but still. All right, I'm gonna look at a hint. Binary search. How do we do binary search in this situation? Width bigger than height. Okay, that's fine. Then we have an array, right? How do we do binaries? No, they're not sorted. If you want to sort, what? It's divide and conquer, and it's split into 3 parts. The central column, the left side, and the right side. And then what? Okay? So if it's in there, then we're done. If it's not in there, it's not in there. So how do we merge? We go through this. We'll compare this. So now we can say it's OM. That is O. That is. But why do you go 3? Why don't you go 2? Divide and conquer. What if I split into 2? We try to find it. We try to find it. If we find it, good. If we don't find it, then and the crossing, right? So we have this, 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 this. We have this. So we only have one for the crossing. We only have one. Right? And then we're going to check this one. And we're going to check this one. Divide and conquer. I'm going to try divide and conquer. It's not binary search, but the divide and conquer. But I'm going to do flow equal to high. Nah. If it's smaller than 3, we can still do. But hold on. If we get into smaller, and so if we get into this, what are we saying? Because if we only have 2, right, it is not going to work. We have to at least have 3. If we get onto 2, then it's bonkers, right? So we say if high minus low is equal to 1, smaller equal to 1, and return this. We're just not able to do. Right? Otherwise, we can split into 2. Then we say left equals helper, low to mid, right equals helper, low to mid plus 1. No. Mid plus 1 to high, right? I'm going to say if left, return left. If right, return right. So if the left or right, we find it, so we just immediately return them. If they don't find, then we need to go to crossing, which is basically we have mid, right? So we have to do mid and then mid plus 1. So we're going to do mid. So we say for I in range, right, all the way to M, for each one, we're going to take a left and take a right. And because mid is here, right? So because high and low cannot be smaller than 1. So high and low at least is 2, right? So if we have 2, so this is 3. And then So the left we have this, and right always taken in this. So for I, so we're gonna deal with mid, right? Say handle the mid column. Mid column will always exist. So we go one to the left. Okay, we say, yeah, we can just be more safe. Say if mid -1 is larger equal to low, right? Then we go through this. We go through this, and then we compare. Right, we compare to the 4. What's J? J is just mid. Then we just say, right, I plus EI, that's going to be mid, because it's I and the mid, right, I and the mid, so mid plus DJ. And we say if this and this is larger than break, otherwise we say else, then we return I and mid, right, so that's that. This is actually not n. It should be high. Small or equal to high. That's fine. Then we do the same. Right, we say handle the mid +1 column. And just say if mid +1, right, that's the column, then +1, so mid +2 is smaller or equal to high. Then we do the same thing. And that will be mid +1 plus DJ. And the same. I is still, we'll go M, J is going to be high. And then if it's good, then we'll return +1. Right? And if it's nothing, then we'll return, we don't have any. So with this helper, we're going to call helper, we can return helper 0, right? N -1. Not sure. Where? J is not defined. Of course J is not defined. It should be mid. It should be mid +1. The first one failed. Oh, oh yeah, for sure. Oh. If one of them, then we shouldn't. Let's say if this and low is not equal to 0 and high is not equal to n minus 1. Right? Which means they're not on both sides. They're not hitting the sides. Then we do this. If they do hit, I can still do this. We're gonna miss. Like in this situation. Shouldn't we go through both columns, right? Then I'll say we don't have this. Think about it. If it's 0, 1, that's 0 and 1, so we go through both. Max recursion. Shoot. I shouldn't do this. Dang. Then this should be different. How about this? If it's larger, then we do this. If it's smaller than 1, whatever it is, we will handle it this way. Okay, this. 1, 0. 1, 0 is fine. Shoot. That's okay. We know 1, 0 is fine. Let's try this. Not good. Oh, pass some. Expect 3, 7. All right, let's see. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8, 9. 3, 4, 5, 6, 7, 8, 9, 10. 4, 5, 6, 7, 8, 9, 10, 11. So, alright, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7. Yeah, that's the only one. What did I get? I got 3, 1. What? How'd you get that? Come on, man. You're tripping. I see. I think this is n because we're doing it. Index out of range. Oh. Oh. Madre mia. Of course. Then I don't need this. Yeah, I thought it was the other one. Gave me the trouble. Yep. Okay. I just change it to include the entire thing. Yeah, because it's fine. It doesn't really matter. Nope. Nope, 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 nope. Interesting question. So this division is now working. Oh, this is like so this is divide and conquer, which runs in O. I say m log n. Right, merging cost is m, not technically speaking 4m, and we divide n, but the actual runtime is still bad. So what's so special about dividing into 3? I don't know. You know, I'll save this for tomorrow. I mean, we already solved it, so it's okay. Just need to figure out a better solution tomorrow. Alright, I'll see you guys tomorrow. Adios.